All right, welcome back to the headquarters. Today we're going to overgo a boiler question. All right, there is your fancy dancy boiler. Put some really cool inlets on it. Far out. And some outlets. There we go. Alright, so we've got a temperature of the feed water equals 40 degrees C, let's say. Boiler. Alright, and the pressure that we're coming in at. Let's say 1400 kPa. Now, often they give us the steam output as a measure of fuel you're burning. So let's say we are 10 kilograms per kilogram of fuel. All right. And we also have our steam is coming out at, let's say, 95%. And finally, a heating value of the fuel of 32,100 kilojoules per kilogram. All right, so let's have a look here at what is going on. There's a couple things we need to recognize first, but let's draw our TH diagram. So we can envision what is taking place. So we know we're coming in at 1400 kPa, all right? So point 1 is somewhere down here. We know we're on this 1400 kPa pressure line. That's BS. I'm going to redraw that for you. That is straight up BS. 1400 kPa. All right. So we come in at a certain pressure, which is this pressure. We heat up that water with sensible heat till we get to point 2, which is the boiling point. And then we heat up that water to where we don't reach saturated. Sometimes we have to do a superheated check out here to make sure we're not, that we need to use table 3. But in this case, they told us we are steam quality of 95%. Therefore, we know 0.3 is inside the dome. All right, now another thing we have to recognize. They gave us, okay, first let's look at the formula. If you look in your book, for the efficiency, your handbook that you get, you will get efficiency for a boiler like this. M, so that's the mass rate of the steam. H1, if you read the fine print, H1 will be H boiler, the enthalpy of the boiler. And you'll have H2, which will, if you read the fine print, will be the enthalpy of your feed water, divided by the mass rate of your fuel, divided by the heating value, whoops, not heating volume, heating value of your fuel. Okay, so if you look at this overall, we know that mass rate times enthalpy equals Q. So this is essentially Q out minus Q in over top of the mass rate of the fuel, the energy we're stuffing in this system. So we're Q out minus Q in divided by Q in. Wow, that's the basic definition of thermal efficiency. Okay? So let's look at what we know. I don't know this, of course, because that's what they've asked for. There's something going on here that I'll take you guys through. Do I know the enthalpy of the boiling water? I know this. I'll have to, I don't quite know it. I've got to do some stuff to get it, and I'll show you that. Okay, and enthalpy of the feed water, no problem. I can get that from the steam tables. steam table 2 at a certain temperature. Why don't I take it at the pressure? Well, the two tables, T1 and T2, table 1 and table 2, give you saturated curves. So that's everything inside the dome, and table 3 gives you superheated. If we want a point where we're not at the boiling point, I need to use the temperature, which is table 2. On the point number 1, we almost always use the temperature. Okay? So I know that. I know the heating value. And again, something tricky, but I'll show you guys this here right now. So one thing we need to realize that, where can I do this for you? Oh, okay. So if I take the mass rate of the steam over the mass rate of the feed water, that's the same thing as saying 10 kilograms, the mass of the steam, the mass rate of the steam is usually 10 kilograms per hour we're given it. But we don't know what it is, so let's call it, I don't know. We could call it hours, we could call it hog's tails, I don't care. Over 1 kilogram, which is the mass rate of the feed water per, I don't know, hog tails. So kilogram over kilogram, these cross out, okay? So we're essentially left with 10 over 1. So the mass rate of the feed water can be 1. The mass rate of the steam is 10. It's just a fraction. It's just a ratio. Okay, so that's how I know those two. It's often given that way to be a little bit misleading, but if you understand that the units essentially cross out, it doesn't matter what these are. Okay, cool. Now the other thing I need to understand or find is the enthalpy of the boiling water inside the boiler, the steam, at that quality. Now we know, we simply use the equation, I want the enthalpy of that, of the boiler, this equals HF of the boiler, plus some quality times HFG of the boiler. Okay, so what we're saying is along this enthalpy line, this point from here to here gives me the enthalpy, that's HF, okay? So right here is my HF, B. Right here, and this whole difference, so this little section is HFB. Let's draw that differently. I want to make that easier for you guys. This whole section is HF right to there, because that goes up to number 2. And then we know that this section that goes right up to the HG is HFG. Okay, so basically what I'm saying with this formula is to calculate the correct amount of enthalpy, I need the HF plus some percent of this heat of enthalpy line right here. That's my HFG. Okay, so I hope that makes sense. I've explained that in some other parts. So we need the HF. We get all that from our 1400 kPa steam tables. So if we go to steam table 1 and we look at 1400 kPa and we get our HF of the boiling water, because that boiling water is at a temperature of, or at a pressure of 1400 kPa. There we are. 830.3 kilojoules per kilogram plus our percentage, which is 0.95, times the HFG for the boiling water at the 1400 kPa. There we go, 1959. So I'm looking this up at steam table 1 at 1400 kPa. I'm finding a HFG. So 1959.7 kilojoules per kilogram gives us an HB of, handy dandy calculator, 2692.02 kilojoules per kilogram. Okay, so now I know this as well. I know that. Okay, I've got enough to solve this equation. Let's stuff in the numbers now. We know this is 10 kg times HB, which we just calculated, 2692.02 minus HF. I gotta go to the tables to get that. So because I'm down here and I'm not at the boiling point yet, I need to use the temperature and not the pressure. So my temperature is 40 degrees C and I'm on this side of the dome, so I'm using HF. The F that I get, so 40 degrees C, table 2, 167.57, 167.57 kilojoules per kilogram divided by, I'm essentially saying 1 kilogram per, we don't know what it is, nor do we care, times our heating value, which is 32,100 kilojoules per kilogram. So the efficiency of our boiler is, and down the calculator, 10, 26, 19. Times 5, we are 78.6%. Okay, I hope that makes sense. I hope that covers the efficiency of a boiler. I really want to make sure that you guys understand everything inside the dome and to the right of it. We do it at the pressure. Anything that's not at the boiling point yet, we use temperature to find the according numbers in our table. Along this side of the dome, left-hand side of the dome is all HF. Right-hand side of the dome is all HG. Inside the dome, this distance, the distance across the dome is always HFG. So that's why we always sketch out these diagrams so we can find that out. That's the lesson of the day. So good day and tally ho.